lungs do more than just supply oxygen to the body and remove carbon dioxide as a waste product. When breathing out, you can expel foreign particles from the larynx and the nasal cavity through coughing and sneezing, and produce sound as air flows over the vocal folds, causing vibrations which in turn causes sound.
When breathing in, odor molecules will be detected by olfactory epithelium in the nose, and that's how we smell. Also, pressure changes during breathing will enhance the venous return to the heart.
The heart and lungs are both found inside the thoracic cavity and are protected by the rib cage. In between the ribs of the rib cage, there are internal and external intercostal muscles which help the ribs move during breathing.
The diaphragm is a muscle that extends over the thoracic cavity and separates the thoracic cavity and the abdominal cavity, but things such as esophagus can penetrate through it, and it assists in respiration as well.
The parietal pleura lines the inside of the thoracic cavity, and the visceral pleura covers the lungs.
The intrapleural fluid is found in between these two membranes, although there's only 10 milliliters of it, but is essential for breathing.
Think of the parietal pleura as the glass, the visceral pleura as the coaster, and the interpleural fluid as the thin layer of condensation between the two. The interpleural fluid reduces friction, meaning the two layers can slide past each other, and provides cohesion, which is essential for breathing.
So many people might think that the lungs are two big inflatable balloons, but the tissue is actually quite dense, and it's filled up with millions of small balloons called the alveoli, providing a large surface area for efficient gas exchange. So we can see the front of the trachea where the cartilages are. It is quite rigid. I'm pressing it quite hardly now, and it is very rigid to protect the trachea from collapsing. This is the back of the trachea. We can see that the cartilage ring is incompleted. When we swallow, the food will slightly compress the trachea.
Here we've cut down the trachea, and you can see it leading into the left and right bronchi. The bronchi supply the lungs with air, and as the bronchi get closer to the alveoli, the amount of cartilage decreases and the amount of smooth muscle increases. Normal quiet inhalation uses both the external intercostal muscles and the diaphragm. The external intercostal muscles move the ribs up and out as they contract, which increases the width of the thoracic cavity. At rest, the diaphragm is domed, and when you breathe in, it flattens to increase the vertical height of the thoracic cavity. Both of these change the volume in the thoracic cavity, which allows the lungs to expand. In normal quiet exhalation, it's a passive process which is caused by recoil as muscles relax and the ribs move back to their original position.
During labor breathing, we'll need the use of accessory muscles, which is the sternocleidoid mastoids and scalenes, helping to pull the ribs up. And during the forced exhalation, the internal intercostal muscle pull the ribs down and in. Abdominal muscles will contract, increasing pressure to help force the diaphragm up. Intrapleural pressure is always lower than alveolar pressure, so it keeps the lungs open. During inhalation, intrapleural pressure lowers furthermore, so it allows the alveoli to expand. This reduces the alveolar pressure lower than that of atmospheric pressure, so air flows in.
During exhalation, the ribs move down, the lungs recoil, intrapleural pressure increases, and air inside the alveoli is compressed. As a result, the pressure in the alveoli increases and becomes higher than the atmospheric pressure, and air flows out of the lungs.
External respiration is the gas exchange between the alveoli and the pulmonary capillaries. Partial pressure of oxygen in the alveolus is higher than the partial pressure in the blood entering the pulmonary capillary. Oxygen molecules will diffuse from the alveoli into the pulmonary capillary. The partial pressure of carbon dioxide in the blood entering pulmonary capillary is higher than the partial pressure of carbon dioxide in the alveolus. Carbon dioxide will diffuse into the alveolus.